Okay, so we've already talked about Dalton's law. If I remember correctly, I believe we were talking about protons, neutrons, and electrons. Is that correct?
Yeah.
Okay,
Left off on molecular and ionic compounds. I think.
perfect. Thank you.
You're welcome.
Yeah, it's funny because, I'm teaching all these classes. I'm like, I'm pretty sure we went over that one. Yeah, I'm sure that we went over that one too. So we were talking about, we've already gone over this one. I remember that, right? Molecular. Did we talk about empirical formulas?
Yes.
Okay, we talked about isomers, spatial isomers, or stereoisomers.
Yes.
Okay.
I think you left
That
off on
table,
figure 2.27.
0.27.
Yeah, right there.
Right here. Okay, so we were talking about the periodic table. So you guys have access to your periodic table, right? I'm gonna pull up. Wow, perfect. Okay, so and so you guys are all familiar with the periodic table, periods and groups, right? Yeah, no, maybe. So I need acknowledgement.
Oh, yes.
Even more so now because you guys are all black screens on my board. I don't see your beautiful faces. I know they're not as pretty as mine, but I still like to see them. Okay, so you guys are all familiar with it, and you guys can find everything on the periodic table. You understand how the periodic table is organized, right? So I'm going to ask you a question. So, do you guys know which group is the noble gases? Off the top of your heads.
18.
18. Good job. So group 18 are noble gases. Did I show you guys the video with carbon, being hugged by everybody?
No,
Yeah.
no.
Yeah, you
Victor
did.
just wants to see it again. I know it. He's like, I want to see it again. He's been wanting to see it again. And he said the same thing on Monday. So we know that the noble gases, they're like the cool kids. They're very stable, right? And everybody wants to be like the noble gases. But they're not currently. Like, for instance, the halogens are one away from being like a noble gas. And we're talking about the number of electrons, because electrons are is going to be what makes a chemical react. It wants to get to the point where it's like the noble gas. It's stable like a noble gas. Okay. And the way that you're going to be able to do that is going to be either gaining electrons, either losing electrons, or sharing electrons. Right. And so if we're gaining electrons, right, then what type of ion does that form?
An anion.
An anion, that's correct. Okay, so if I'm losing electrons, then that forms what? And you got to show the symbol, so that means you got to show me your screen and everything. Hello? Anyone there?
Yes.
Okay, so then you're going to tell me, right?
Losing electrons?
If I'm losing electrons, it forms what type of an ion?
Cation?
A cation. Okay, so we know that gaining electrons, we form an anion. What's going to be the charge on that? For an anion. What is the charge on an anion?
A negative charge.
It's going to have a negative charge. And then a cation,
Positive.
it's going to have a positive charge, right? So let's say we have potassium. We know that potassium is 1 away from being a noble gas, right? Let me pull up my periodic table real quick. Hold on. Can you guys see my periodic table?
Yes.
Yeah.
Okay, good. Okay, so we're talking about potassium, right? So potassium, which is it's in group 1 and period 4. Potassium is 1 away from being a noble gas. So potassium, since argon is here and krypton is here, right? Okay, so let me take one step back. So potassium has options, like all of the elements have options. So they have the option of either gaining electrons or losing electrons. Most metals, or almost all the metals, are going to want to lose electrons, right? And it's kind of where they're located at. It also deals with energy, right? It's about how much energy it takes to do it, right? So if it has to gain electrons, it would have to gain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 electrons to be like krypton. Okay, so that's kind of like, let's say there's 2 stores that are exactly the same. One is 1 block away and one is 18 blocks away. Which one, and it's a really, really hot day and you have to walk to get there. Which one would you want to go to? The one that's 1 block away or the one that's 18 blocks away?
1 block.
1 block.
So we would want to go to the one that's 1 block away, right? Because one thing is that we're lazy. Like in nature, I'm going to try to find the quickest way of doing it, right? I could possibly do it, right? 1 block away is a lot closer than 18 blocks, okay? It's going to take so much less energy. Now, these elements are just like us. They want to use the least amount of energy as possible. You know, they don't want to use too much energy. They want to kind of keep it low energy, right? They're lazy, just like us. So in that case, it's a lot easier for a potassium to lose 1 electron rather than trying to gain 18 electrons. Does that make sense?
Yeah.
Okay. So we know that potassium is going to have a +1 charge when it loses that electron. Now let's say we have chlorine. Chlorine is located here. It's 1 away from argon, or it could try to lose 7 electrons and become like neon. So which one do you think it's going to do? Gain 1 or lose 7?
Gain 1.
It's going to gain 1. So if it gains that 1 electron, it becomes a negative charge. Now, we kind of talked about this. I know that we talked about it. It's that opposite of that positive attracting, right? We talked about it because I talked to you guys about, you know, the boy or the girl that was the bad influence, right? You guys remember that in class?
Yeah.
Okay, good. So we know that these guys, because potassium is going to be positive and chlorine is going to be negative, if we put them both in the same container, they're going to interact with each other and they're going to form a compound, potassium chloride. Okay, now this ion on its own is going to be called, the potassium ion. Now this ion here, because it is a negatively charged ion, right? We need to give it a different name. Instead of calling it chlorine, we call it chloride. Chloride ion. Now when we put it together, we call this potassium chloride. Okay. And you'll notice it doesn't have a charge associated with it because it has to balance each other out completely. So do you guys remember when I was talking about dating a crackhead or a meth head or anything like that? Remember those stories?
Yes.
Okay, good. I'm glad that you guys remember that. So now I said that when you date a crackhead or a meth head, you can't balance them out because they're like off the wall. They're just too much, right? And so it would take several people to balance them out. So they're very difficult to date because of that, right? So if we have cases where we have ions that are forming, so let's take a look at aluminum. Erase these first. Aluminum. Okay, now aluminum, is it going to form a positive ion or is it going to form a negative ion based upon where it's at?
Negative.
Are you sure? So negative means that it would gain electrons. Okay, so aluminum is right here. So if we went here, that's 1, that's 2, that's 3, that's 4, that's 5. It would have to gain 5 electrons, right? But if it loses electrons, that would be a different color. Yeah, green. So that'll be 1, 2, 3. Now, Juan, would you want to walk 3 blocks on a really, really hot day, or would you want to walk 5 blocks on a really, really hot day?
3 blocks.
3 blocks. So if you're walking 3 blocks, in other words, if you're losing 3 electrons, you're going to have what charge?
A positive.
Positive. Positive what? You're losing how many electrons? To be like that noble gas, that's 1 here, that's 2 here, that's 3. So it's going to be a positive 3. Do you guys see that?
So you
Yes.
count the actual like noble gas slot, not before it.
Yeah, you'd count the actual, because you're starting, it would be the point that you're starting from, so that's aluminum. So technically, it already has that electron, so you have to lose that first one to be like magnesium, and then you have to lose the next one to be like sodium, and then you have to lose one more to be like neon.
Oh, okay, thank you.
Okay, so it's going to have a +3 charge. Now let's say we're hooking up with iodine. Okay, so iodine is going to have what charge associated with it? Okay, this is interactive. What is going to be the charge on iodine?
-2.
Okay, now remember you're starting here, right? And how many does it need to gain to be like neon? So you're here already. You're just going 1 over.
Okay, so then just
So then it's going to be
-1.
-1.
Yeah.
That's right. Okay, so if I'm -1 and aluminum is +3, is that going to balance out to be 0 exactly?
No.
It isn't. Okay, so that means that we're going to need more of which one?
Iodine.
So we're going to need a total of 3 iodines to balance out crazy aluminum. Okay, so then aluminum would have 1, and then we put the subscript 3 to let us know that we need 3 iodines to balance out that. Do you guys see that?
Yes.
Okay. Questions?
No.
Good. Okay, so I'm going to put a couple up there. I'm going to put a couple of pairs up there. I'm just going to give you the elements. I want you to tell me the ions that they form. And then I want you to balance them out. And then I want you to tell me their name. So what would be the name of this compound? Based upon our last name that we did. So before we start, I'll kind of give you a little bit of hint on this one. Okay, so group 1 metals and group 2 metals, right? So those guys, group 1 metals are always going to have a +1 charge. And group 2 metals are always going to have a +2 charge. Okay. Now, aluminum is always going to be a +3 charge. Boron, if it's going to be because it's a metalloid, if it's going to be act like a metal, it's going to have a +3 charge. If it's going to act like a non-metal, it's going to have a 1, 2, 3, 4, 5 -5 charge, which it's not going to want to do too much of, right? Because it's too much energy. Okay, so in this case, all we would have to do to name this guy would be aluminum iodide. So we changed the iodine, the INE, to IDE. And then we, that IDE serves two purposes. One of those purposes is to let me know that it's going to be a negatively charged compound, or it could also tell me that it's the end of the compound. So at the very end of compounds, we usually use IDE, but we also use it to tell us that it's a negatively charged. And that means that when we write the chemical formula, right, we always put the positive ion first, and then we put the negative ion. So we have the aluminum would go first, and then the negative ion would go last. Do you guys see that?
Yeah. Question, if aluminum had like a number after it, would it change the first part?
If we had Al3 here,
Mm-hmm.
no, because that Al3 is going to be compensating to try to balance it out. I'll give you an
Oh,
example of that in a minute. Okay,
Gotcha.
that's a good question. Let me give you an example of that, and then I'll have you guys start telling me the ion names and all of that. Okay, so let's do one that's a little more complicated. So we'll use aluminum for example. So we'll keep aluminum. And let's use oxygen. Okay, so what is going to be the charge on aluminum when it forms an ion?
You kind of cut off. Can you say that again, please, Dr. Henry?
Yeah. What is going to be the charge on aluminum if it forms an ion?
Positive.
Positive what?
3.
3.
Okay, it's going to be +3. And then oxygen, what is going to be the charge on the oxygen?
-2.
Okay, so it's going to be a -2. Okay, so how many aluminums will I need to balance out the oxygens? And how many oxygens will I need to balance out the aluminums?
Two aluminum and 3 oxygen.
Said 2 aluminums and 3 oxygens. Okay, so then we'd write this chemically, the chemical formula as Al2 O subscript 3. Okay, you guys see that?
Yes.
Yeah.
Okay, so then when we name this, it's still going to keep the same name. It's still going to be aluminum oxide, because oxygen is always going to have a -2 charge associated with it. And aluminum is always going to have a +3 charge associated with it. So we don't need to add anything extra. And so we'd call this aluminum oxide. Okay, questions?
Could you do another example, please?
Sure.
Thank you.
Okay. Can I go ahead and erase this one? And
Yeah.
is everything showing up on your side as well? Because sometimes I think it shows up on my side. I see it on my side, but it may not be showing up on your side.
No, it's showing.
Okay, good. Okay, so let's do. Let's do. Rubidium. And selenium. Okay, so what is going to be the charge on rubidium?
+1.
It's going to be a +1 charge. Okay, and selenium?
-2.
-2. Okay, so then how many rubidium am I going to need to balance out the selenium?
2.
So I'm going to need 2 of those. Okay, so then my chemical formula is going to be this is where you guys chime in. Said I needed how many of rubidium?
2?
2. So I'm going to use a subscript of 2.
Mhm.
And then how many selenium should I have?
1.
1. Okay, so then what would be the name of this compound? Rb2Se.
Rubidium selenide.
Okay. Rubidium selenide. Okay. Questions? Concerns? Cash? Okay, good. Okay, so you guys ready for another level? So you were here, we're gonna go to the next level.
Sure.
Okay, so now remember when I told you guys when I first learned chemistry and everything like that, they really didn't talk about the transition metals. There was minimal that we talked about transition metals, right? Part of that is because that term transition, right? So if we think about trans in general, like transsexual, transvestite, trans, what does that mean to you guys? What does trans mean to you? Transition.
Like
Tra-
different,
What was that?
like different.
Different? Okay.
Transition would be like one thing to another. So
So like a change?
yeah, change. There you go. Yeah.
Change. Okay, good. So it's like a change, right? So the thing about transitional metals and post-transitional metals and your lactanoids and your actinoids, right? All of those, they can go through changes. What we mean by that is that their ability to become stable is going to be a little bit different than the ability of all of the ones that are in the main group, right? They're not looking just to be like a noble gas. There's other things that they have to take in consideration. Because there's other things that they have to take in consideration, that means that they have to, they could have different changes, okay? So for instance, we have iron, right? Iron has, there's Fe2+, there's Fe4+, there's Fe6+, and I think, oh, I forgot Fe3+, Fe3+. Okay, so now it could be Fe2+, it could be Fe3+, it could be Fe4+, it could be Fe6+, right? Now, some of these are more rare than others, but it has that ability to sit there and do it. And it kind of decides what charge it's going to be depending on its width and how it's behaving with that particular things, the conditions that you're making that compound, right? Those are some of the factors that can dictate whether it's going to be a 2+ or if it's going to be a 3+, right? Or a 4+, okay? So we have to sit there and be able to distinguish between Fe2+, Fe3+, and Fe4+. The way that we do that distinction between them is we use Roman numerals. Are you guys familiar with Roman numerals?
Kind of.
Yeah.
We're going to test it out here. Okay, so if I have I, what does that represent?
1.
1.
Okay. If I have I,
2.
2.
if I have I,
3.
if I have IV,
4.
4.
if I have V,
5.
5.
if I have VI,
6.
6.
VII,
7.
VIII,
8.
and IX,
9.
and XI. I mean X.
10.
Okay, so you need to know up to 10, mostly. Trying to think if there are any ones that will go up to 14, but you get the idea, right?
Yes.
Anybody not familiar with Roman numerals? Good, okay. So the way that we would name this ion, this first one, the Fe2+, we would call it iron 2 ion. So the Roman numeral will tell us the charge on the ion. Not how many we have, but it's the charge on the ion. So then I would name Fe3 plus what?
Iron, ion.
Iron, ion, or iron 3 ion. Okay, and then Fe4 plus
It'd just be iron and then 4 I's.
would it be 4 I's?
Oh no, the I and the V.
IV, yes. Okay, and then if it's iron 6 plus,
V and then I.
okay, that's it. Pretty simple.
Yep.
Okay, good. Okay, so that's going to be the case for transitional metals. So with our transitional metals, most of them, there are exceptions, but most of them are going to require you to put a Roman numeral next to them, okay? And then that's also going to be the case with most post-transitional metals as well too, okay? So let me give you an example. Everybody got this down so I can erase my little board?
Yes.
Okay, so what if I have, let's say I have this. Or this. Okay, so what would be the name for Bi 5 plus?
Bismuth 5. Or
So how would I write that? Is myth. Did I just put bismuth 5?
V.
I put bismuth V. Okay, ion. Okay, what about Ni plus?
Nickel
nickel.
1.
Okay. And then what about copper? I mean, Cu 2 plus.
Copper II.
Okay, questions? Somebody has a question. Okay, cool. Okay, so you guys got the hang of it? Good, bad, ugly?
Okay.
Okay, so I'm going to clear this. I'm going to do something a little bit different. So let's say we have, we use bismuth 5 plus. And then we have O2. I mean O2 minus. Okay, so what would be the compound that they would form, and what would be the name? Oh, by the way, do any of you guys have a Chromebook?
I do.
You do? Okay, so you're going to be my exception. Everybody else, if you guys, if you go to your, it says you're viewing Dr. Henry's screen or Kenneth Henry's screen. Do you guys see that?
Yes.
At the very bottom next to it, there should either be ... or there should be options or something like that. If you click on that, you'll see something that says another window or menu pops up, and it'll say annotate. ANNOTATE. Click on that, and then another menu will pop up. There we go. Good job, Juan. So if you can do me a favor and sign your names over here where it says sodium, so like right here. So I can see everybody who's here and who's able to write. Boy, somebody has really big handwriting there. And if you're using your phone, you can also, there's a pencil that'll allow you to sit there and write as well too.
I can't find it, Dr. Henry.
Me neither.
So there's a green, like little green slab underneath the menu at the very top. It'll say you're viewing such and such. And if you go right next to that, it'll say options, or it'll have dots or something like it. If you click that option.
So since I do have a Chromebook, do you want me to just watch right now?
Yeah, you can just watch. You can't, yeah, if you have a Chromebook, you can't annotate it.
Okay.
Did you find it, guys?
Yeesh.
Yeah.
What about the two that said they couldn't find it?
No, mine just says view options. It says you are viewing Dr. Henry's screen, and next to it says view options, but
Okay,
it
so
doesn't show
cool.
annotating.
If you select view options, select that part.
Okay, and it pops up fit to window, original size, and request remote control.
Okay, so then you have a Chromebook.
I have a MacBook Pro.
You have a MacBook Pro?
Yeah.
Ah, so then that means that you didn't download the program, you're using.
Yeah, I've been having trouble with this, so I'm using the browser to do
Okay,
it.
so then that's the reason why.
Okay.
Yeah. Okay,
I'm using my phone. I'm not sure how to do it.
so on your phone, there should be at the very bottom, there should be a pencil.
Yeah, the pencil's there.
Okay, so you just select that pencil and then you could write on the screen.
It's gonna be pretty big.
That's right.
I can't draw small.
So height says it's going to be bismuth 5 oxide. It's going to be the name. So what's going to be the formula for the bismuth 5 oxide? So the name is correct. So what would be the chemical formula? Anybody want to write on the board the chemical formula? You know, since Victor writes really big already, so then we're going to have Victor do it. How about that, Victor?
Damn. Oh, wait. I messed up.
Okay. So another way of looking at it, that's a good job. Very good job. So usually you can sit there and do what we call like that cross multiply part. So then this guy's going to need 5 of them to balance it out. This guy's going to need 2 of them. So bismuth 2, O5. Now that works when you have an odd and an even number, right? For your charges. Okay. What happens if I have something like this? Let's do. Okay, what would be the name for that one? And the chemical formula. Let's see. Who's going to volunteer? Or does somebody have to be voluntold?
Is it tungsten sulfide?
Okay. So you're going to say tungsten sulfide. Are you missing anything?
The tungsten VI.
Okay. Tungsten VI sulfide. Okay. And then what would be the chemical formula?
WS3.
Okay. Piece of cake?
Ye.
Okay. Okay, so I'm going to go ahead and clear this, and then we're going to move forward. Maybe. Okay, so this is just basically showing you what happens to get that charge where we're losing an electron. So like here we have sodium, it has 9 electrons. Now when it becomes the sodium ion, it has 10 electrons. It lost that 1 electron. So usually it's giving it away to something else. The reaction, they'll be giving it away to something for that to happen. So we know that group 1 is going to lose 1 electron always. Group 2 metals are always going to lose 2 electrons. Okay, so then that means group 1 metals are going to have a +1 charge. Group 2 metals are going to have a +2 charge. On the other side, halogens, group 17, they're going to gain 1 electron. So they're always going to have a -1 charge. Group 16, the catogens, those guys are going to lose 2 electrons, and so gain 2 electrons. So they're always going to have a -2 charge. Okay. So you guys are already able to predict charges? Feeling comfortable with that? Yes, no, maybe?
Yeah.
Okay, good. Okay, so these are some of the ions that you'll see and you'll come in contact with. There are others that you'll come in contact with, but these are just a few of them. And you'll notice those transitional metals, you have copper 1, you have copper 2, right? Ions, you have gold 1, gold 3 ion. And so you'll notice that you have this. Now, the one thing that I want to add to this is that the metalloids, these guys, now remember, they can act like a metal or they can act like a non-metal. So if they're acting like a metal, they're going to have that plus charge. If they're acting like a non-metal, they're going to have a minus charge. Okay, so like in the case of silicon is right there in the middle. So if it loses 4 electrons, it's going to be like neon. If it gains 4 electrons, it's going to be like argon. So, and it's also a metalloid, so it can go both ways. And that's kind of like carbon, technically. Carbon can go both ways. It has the option of either losing 4 electrons or gaining 4 electrons. It's about the same amount of energy, although it has a preference towards gaining those electrons. Okay. So are you guys with me? So when we're talking about metalloids and it's acting like a metal, we have to put the charge next to it. So we have to put its charge. So it's going to be 4+. So we have to let us know that it's going to be 4+. Does that make sense?
Yeah.
Okay. Okay, so let's see if you guys understood that. So let's say we have this compound. Okay, so what would be the name of it? And then what would be the charge on the silicone? So we'll have you guys do A and B.
Dr. Henry, you said when we gain like gain an electron, it would be negative.
If we're gaining an electron, it would be negative. That's right.
Okay.
If we're losing electrons, it would be positive. Are you sure? Ricardo. Are you sure? Are you sure, Kevin? Are you sure? Reina. That's right. Bet on it. So you're going to bet on it? Which one are you going to bet on, Scarlett? Okay, so let's talk about the first one. Okay, so again, it's a metalloid, right? So the metalloid, since it's a metalloid, it has the option of acting like a metal or acting like a non-metal. So here it's acting like a metal, okay? So it's going to form an ionic compound in this context. So if it's acting like an ionic compound, then we have to give it its charge, okay? If it was acting like a covalent compound, covalent meaning that they're sharing electrons, and if they're all non-metals, they'll be sharing electrons. We haven't talked about how to name them. So that's like the seven. So nice try, Kevin. Okay, so we would call this guy, what would be the charge associated with silicon? Anyone?
It's a negative or positive 4.
Positive 4. So we would call this guy silicone or oxide. What would we call this guy down here? Now here, silicone is acting like a non-metal. So what would be its name?
Wait, why does silicone act like a non-metal in this one?
On B, second, with the manganese. You see
Oh,
the
okay.
imp down here?
Yeah.
So what would be its name? Reina, do you want to give it a go? And Scarlett's going to be your backup. Okay, so Reina says it's going to be manganese. Manganese 2. She said silicate. Okay, so that's what you have written down. Is that correct, Raina? Manganese 2 silicate. Do you guys agree with that? And if you do, tell me why. And if you don't, tell me why. You said no, they go solo. What do you mean by that? Okay, so Kevin says silicate is SiO3, which is correct. So we know that this is not silicate, because silicate would be SiO3 2 minus. Okay, so can't be the 8 at the end. So what should it be at the end? Anybody want to help out with that? What should that ending be? So we know it's not 8. What should it be? Silica. So you're saying just an L at the end? Does that tell me silica? Is that right? Ah, somebody put "ide." That's right. "Ide." That lets me know that it's a negative ion. So it's an anion, right? Okay, so it should be "ide." Now, we know that if it's silicide, what is going to be the charge on silicide? It's located right here. So then we know that it's a negative ion. How many electrons is it going to gain to be like that noble gas? 4. So it's going to have a -4 charge. So then that means that manganese must have a what charge associated with it? What would be the charge? So you're telling me, you told me, you said manganese, Mn, has a 2+ charge. That's what you just told me, right? So does +2 and -4 equal 0?
Nope.
No. So it can't be a +2 charge. What does it have to be? Because we only have 1 manganese here. We don't have 2. So what has to be the charge on that manganese?
Four.
Okay. Kevin and Victor, I believe that was, said 4.
Yeah.
So it's going to be a +4. And that +4 is going to balance out that -4, right? And so then we have a total of a 0 charge. Okay, so then what should be the Roman numeral?
Four IV.
So it should be IV. Okay, do you guys see that?
Yeah.
Still kind of a little confusing, but we're getting there.
You're getting there. Okay.
Yeah,
Dr.
it's-
Henry,
What was that?
how do you know when a metal acts as a metal and when it acts like a non-metal?
So you know that it acts like a metal if it's in the front, and then you know that it acts like a non-metal when it's in the back. So that's typically, right? Now, the only thing is that sometimes they're going to act covalently, right? And then that's going to be a little bit different, right? And so you'll need to know a little bit about the connotation that you're using. Does that make sense?
Yes, thank you.
So like for instance, silica 4 oxide, it is an ionic compound, right? So are you guys familiar with quartz and stuff like that? Rocks,
With what?
quartz.
No.
Like not a quart, but as in quartz as the rock quartz.
I'm not too into rocks, sir.
Poor thing. Like your birthstone. What is your birthstone?
Yeah,
I do not know.
rose quartz. I've heard of that.
Okay, yeah.
Yeah.
So you guys are familiar with, you've heard of rose quartz, okay? And you've heard of the amethyst and all of those, right?
Yes.
So those are all examples of the case where silicone is acting as an ion, right? They form that rock type structure, right? So that it's that metalloid that's kind of acting like a charge particle, okay? And so they're going to be different, right? The colors are going to be different based upon their organization and how they're behaving. Okay. So your job is, I should give you an assignment, learn your birthstone. Any of you guys know your birthstones? Everybody says yes, yes. Excellent. So you guys can learn your birthstone, and then I want you to give me the chemical formula for your birthstone. Okay. That's going to be your next quiz. Okay, let's see. So the next thing that we're going to talk about is the polyatomic ion. Maybe. Is it okay if we take a 5-minute bathroom break?
Yes.
I'm drinking a lot of fluid since I'm under the weather, so that's okay.
Yeah.
I'm gonna put you guys on mute as well. Okay, so there was a question. I have a question. How do we know what suffix applies? Okay. So we're gonna get to all the different suffix. So if we have just the element by itself, let's say S2, okay? We're always gonna use "ide." If we have an ion that is negatively charged, we're going to be using "ide." If it's just a single element. Does that make sense? Or a single atom. Okay, so this guy is called sulfide, right? This ion, this is a sulfide ion. If we have P3 minus, then that would be called okay, don't all you guys yell at me at once. You guys are just talking way too much. P3 minus.
Would it be phosphide?
Phosphide. That's right. Okay, so we drop all the other gunk and we drop that part and we just put "ide" at the end. Okay, does that make sense?
Yes.
Raina? Okay, so now we're going to get a little more complicated because we're going to start talking about polyatomic ions. And so the suffix is going to change for polyatomic ions. So far we've only talked about monoatomic. What does monoatomic mean?
One, singular.
1. Okay, so I need you guys to do me a favor. I would like you guys to pull out your packets, go to page 5 of your packets. And on the top, it should say common polyatomic ions. Something along those lines. Okay, everybody did that? Yes, no, maybe?
Yes.
Okay, good. Okay, so monoatomic basically means that we had only one type of atom. So in that case, we have only sulfur, right? So that would be a monoatomic ion. Okay, and we know that those, in the case of sulfur, when they're an anion, we put IDE at the end. Okay, now polyatomic ion it's a combination of us having covalent bonds and extra electrons added onto it. So for instance, if I have SO4, 2 minus, this here is called a polyatomic ion. So overall, the SO4 has a -2 charge associated with the entire thing, but they're covalently bonded together. The S and the O's are covalently bonded together. So they're sharing electrons. Okay. So this would be called a polyatomic ion, and this guy would be called sulfate. So that ATE at the end of it means that there's oxygens added onto it. Okay. So I'm going to give you some names that I want you guys to look at. So we had, let me move these over. I'm going to write the ion over here. I'm going to write the name on the other side. Easier. That's okay. Or maybe we'll see. We'll put them all on the same side. So then that way you guys don't have to worry about moving stuff. If I can get things. So for instance, as I said, this guy's called sulfate. If I have one less oxygen, it's going to be called sulfite. If I have one less oxygen than the sulfite, it's going to be called hypo. Do you guys know what hypo means? Sulfite.
Like extreme?
Not hyper, hypo. Like hypothermic.
Below.
Below. It means below, right? So it's below sulfite. Okay, so it's called hyposulfite. So sulfate has 4 oxygens. Sulfite has 3 oxygens. Hyposulfite has 2 oxygens. You see that? But you'll notice the charge of them is still -2. Okay, so there's one more that I want to talk to you guys about, and that's SO5, 2-. So here we did something. If somebody is extra or above and beyond, or a kid that's like just bouncing off the walls, we call them what?
Hyper.
Hyper, right? So as chemists, we didn't want to get you guys mixed up with the hyper and the hypo. So what we do, we just put per. So we'd call this guy persulfate. Okay, so if it's 1 greater, we put per in front of it. That means we're adding an additional oxygen. Do you guys see that?
Yes.
Okay.
Yeah.
So let's see. If we start off with PO4, and this guy's going to have a 3 minus for its charge. So this guy would be called what? You can find it on your polyatomic ion table.
Is it phosphate?
It's called phosphate. Okay. So then tell me what perphosphate is going to look like. What is going to be the chemical formula for perphosphate?
PO5 -3.
Okay. So perphosphate is going to be PO5 with a -3 charge. And that's going to be perphosphate. Can you guys see it if I type it over there? I think you have to move your pictures of me, I guess. Okay, so what would be phosphite? The chemical formula for phosphite.
PO3 to the 3 minus.
Okay. And then hypophosphite.
PO2 to the -3rd power.
Okay, and phosphide.
PO to -3.
Are you sure? Remember that IDE? What does that IDE stand for? That's right, Raina. T 3 minus. Okay, questions? Okay, so there's a couple things that I want you to remember and to kind of keep in the back of your mind. One of the things that I want you to remember is that if they're in the same group, they're going to behave very similarly, right? So if they're in the same group, they're going to behave very similarly. Now, also with the common polyatomic ions, sometimes you could end up having a metal in there that's acting as a polyatomic ion. Okay, so like for instance, on your sheet, you have chromate. Do you guys see chromate?
Yes.
Okay, so what is the chemical formula for chromate?
CrO4 to the -2.
Okay, so chromate is a metal that is being attached to the oxygens. And so here, remember when I told you that those transitional metals are going to sometimes act a little weird, right? So in a sense, it's kind of sharing. It's interacting with oxygen differently than it normally would if it was just a normal metal, right? So this is a special case. Does that make sense?
No, can you repeat that one more time?
I said here, this guy is going to act as a polyatomic ion. So they're acting as if they're sharing the electrons in this context, right? So the oxygens will be sharing the electrons that the copper has, the chromium has. And so
Okay.
this is a special case, right? So normally it's give and take, but here chromium is acting a little bit different. Okay, now some of the other transitional metals will do the same thing. And so they'll form these special compounds, like in this case, the chromium did. So we call this guy chromate, right? Instead of just calling it chromium oxide or chromium whatever oxide, right? Does that make sense?
Mm-hmm.
Okay. So, and if I have Cr2O7, 2 minus, what's that called?
Dichromate?
Called dichromate. Okay. So now when we're in the same group, we're going to behave similarly, right? So what I'd like you guys to do is, I'm going to put a compound up, a couple of them maybe. And okay, so I put up 4 names. So what I'd like you guys to do is give me the chemical formula for those names. Now, again, take into consideration that the ones that are in the same groups are going to behave very similarly. Okay. Let's see. See who's on my list. So Kevin, do you mind doing polonate? I'm gonna have Stephanie, selenite, Alejandra, hyponitrite, and Alyssa, per iodate. Okay, you guys gonna write on my board, right? Kevin, are you there?
Yeah.
Okay, you gonna do polonate for me? What group is polonate in? Or polonium, sorry, polonium.
Sixteen.
Which group?
16.
Group 16. Okay, so we're in group 16. Who else is in group 16 that we know a little bit about in terms of polyatomic ions?
Oxygen.
Oxygen and what's below oxygen?
Sulfur.
Sulfur. Didn't we just do sulfur? Over here on the side, you still see it in green? Persulfate, sulfate. Okay, so then if it's polonate, the only thing that we're doing is we're going to substitute the sulfur for the polonium. So then what is the symbol for polonium? Polonium.
PO.
Yeah. Okay, how many oxygens would I have? Since it's an 8. 4. So I have PO, capital O, 4. And what would be the charge on it?
Will be -2.
That's right. Because it's going to behave just like the one in its same group. Okay. Do you guys see that? Good job, Raina. Okay, who had selenite?
That was me, but I'm still confused.
Okay. So Alejandra, is that right? Or was that Stephanie? Stephanie. Sorry, Stephanie. My bad. Trying to recognize the voice because you know it lights it up if you're on my screen, but you weren't on my screen. Okay, Stephanie. So let's talk about it. Where is selenium located at?
It's group 16.
Group 16. So, and that's also in the same one as who's above it?
Sulfur.
Sulfur. So it's going to behave like sulfur. So in this case, we have an ITE. So then how many oxygens did sulfur have when it was just ITE?
Is it 1?
Look on the board. How many oxygens?
Oh, 3.
At 3. So we're going to put 3 oxygens. And then what is the symbol for selenium?
Se.
Se. And so what's going to be the charge? What was the charge for sulfite?
-2.
Okay. Do you see that now?
Kind of. I think I just did more practice.
Okay. Okay, so again, the ones that are going to be in the same group are going to behave similarly. There's only one exception, and that's nitrogen. Nitrogen is its own beast. So who had hyponitrite?
Me, but I'm still confused too.
Okay, so let's work through it. This is Alejandro now, right?
Uh-huh.
Okay. Okay, so do me a favor. For nitrate,
Mm-hmm.
can you find that on the table, on the polyatomic ion table?
Oh, yeah. Hold on.
What is the chemical formula for nitrate?
NO2. Wait, NO3.
NO3.
And it has a negative charge.
That's right. It has only one negative charge. So that would be
Mhm.
nitrate, ATE,
Okay.
right? So then let's work our way down then. Okay, so then if we lose one oxygen and have NO2, that's going to be called what?
Nitrite.
Nitrite.
Oh, okay, yeah. And then
So then if I lose one more oxygen, then that's going to be called,
hyponitrite.
okay,
Oh, yes, I
which would be no minus, right?
Uh-huh.
Capital N, capital O minus.
Okay.
Okay.
That makes sense.
How that works?
Yes.
Okay. Let's see. Who did I give? Alyssa had per iodate. Okay, Alyssa. Where's iodine located at? Which group? Remember, the groups are up top and periods on the side. Are you there, Alyssa? Okay, that's all right. We'll get Andres to take Alyssa's place. Andres, you want to help me out? Okay, well, no Andres either. Christine,
Yes, I'm here.
do you want to help me out?
Sure. Yeah, I'm still kind of confused too.
Okay. So what group is iodine in?
Iodine?
Yep.
Group 17.
It's group 17. Okay. So is there some element that is similar to iodine that's in the same group that is on our polyatomic ion table? Like what other groups, what other elements are in group 17?
Oh, sorry. I think my internet cut out for a second. Can you hear me now?
Yes. What other element is in group 17?
Bromine, chlorine, fluorine.
Okay. So is there something like chlorate on our polyatomic ion table? Or bromate? Bromate or chlorate?
Yeah, chlorate.
Okay. So what is the chemical formula for chlorate?
ClO3.
ClO3.
Yeah.
Okay. What charge?
Negative.
just a single negative.
Yeah.
Okay, so if I add an oxygen to chlorate, what would I call that? So if I have ClO4 now, what is that called? So when we did it to sulfate, when we added an oxygen, to sulfate, it became what?
Persulfate.
Persulfate. So then this is going to be called
Perchloride.
perchlorate.
Chloride.
Okay. So if perchlorate is ClO4 minus, so then what must be per iodate?
Per iodate would be.
What do you think the IODA is standing for?
PO4.
Would it be PO4 or would it be
Sorry, IO4.
IO4? Okay.
Mm-hmm.
And what charge?
Negative.
That's right. So it's going to be IO4 negative.
Okay.
Okay.
So
Not too
wait,
bad.
all these little things are like kind of connected, huh? Because I didn't.
Yeah.
First of all, you lost me because you said iodine, and then we went to chlorine, and then we went back to.
Yeah. Yeah,
Okay.
they are kind of connected, right? So that's part of the reason why I have you guys have the periodic table in front of you. I mean, the polyatomic ion table in front of you. And so that you can use that as a tool to sit there and get all of the others, right? So if you have that table and if you learn that table, all of the other ones will come along because they all obey the same type of rules.
So we have to like kind of memorize the periodic table too then, huh?
Yeah, in a sense. And you will. I mean, the more you use it, the more it sticks up there, right? Because I could tell you like all of the ones that are in group 17, right? I could tell you most of the ones that are in group 16. I can give you the upper part of group 15, because I use it so frequently. It's the ones that I don't use that frequently, a lot of those transitional metals, right? Those are the ones I have a hard time remembering, and where they locate and, things like that. But it's exposure. And
Okay.
it says, does group 17 have the oxygen numbers for each per / suffix? Yeah, so they're going to behave very similar to what we saw with all of the other. Like when we have per suffix ate. So anytime we have per, it has to end with ate. And then let me kind of underline that so you guys can see this. Per is always going to have end with ate. And then you just have ate, and then you have ite, and then you have hypo, and that's always going to end with ite. Does that make sense?
Yeah.
Okay. So when we start putting it all together, right? Our next part, and then I think we're going to stop after our next part. Hopefully we'll all be in class because it's a lot easier to see in class than, because I know that we get distracted when we're at home or on Zoom. And plus, it's really hard to stay focused on a black screen. Okay, let me clear this up a little bit. Do you mind if I erase everything? Everybody got it down?
Yeah.
Okay. So let me go to my next slide. And then we'll start pulling it all together. Okay, so these are some of the common polyatomic ions. These are the ones that you should definitely know. So you should somehow put those in your head. So ammonium, which is ammonia. You guys heard ammonia, right? We have ammonia plus an additional oxygen. Okay, so that's what ammonium is. So ammonia is NH3, which you should know. That's ammonia. So ammonium is just NH4 plus. Hydronium is water with one additional H, right? And it has a plus charge. So that's going to be your hydronium ion. So those are your only two polyatomic ions that are positive. Okay. Then we have peroxide. Peroxide means that we have O2 and it has a negative 2 charge for O2 together. We know that O by itself, which we call oxide, is just this, right? We have hydroxide, we have acetate, we have cyanide, azide. Azide is N3 minus. Carbonate, CO3, 2 minus. Bicarbonate, well, we just have an oxygen added, a hydrogen added onto it. And that also will cause that charge to be a negative instead of 2 negative. We have nitrate, nitrite, sulfate. Hydrogen sulfate means that we added a hydrogen to that sulfate, and that hydrogen has a plus charge to it. So it makes that overall charge a minus now. We have sulfite. We have hydrogen sulfite. Here we add that hydrogen. I added that hydrogen, and it adds an H plus. So now our charge is a minus. We have phosphate. And then we have hydrogen phosphate. Okay. So these are the ones that you're going to see a lot of. Now I'll throw a couple of them in for you because you need to remember that groups are going to behave very similar to each other. Okay. And again, your exception is going to be nitrogen. Nitrogen is that exception. Okay. The last thing that I want to go over, and then we'll stop here, is bringing it all together. Okay. So if I give you a name like bismuth, bismuth for sulfate. So we need to be able to write the chemical formula for that. Okay. So we know that sulfate has what charge associated with it?
I'm sorry, you said sulfate?
Sulfate.
A 2 minus?
A 2 minus. That's right. And then here, bismuth has what charge associated with it?
+5.
Here I have IV.
Oh,
What does that mean?
4.
4. So it's Bi with a plus. Okay, so how many sulfates will I need to balance out that Bi? 4 plus.
4.
On a 4? Are you sure? So I have SO4, 2 minus. SO4, 2 minus.
2 then.
SO4, 2 minus. Will I need 4? Because then that's 2, 4, 6, 8.
Just 2.
I just need 2. Okay, so I'll need 2 of those. Right? So then when I write the chemical formula, it's going to be Bi parentheses SO4 parentheses and then 2. Okay.
Wait,
And
why
so
is
you,
the 2 at the end?
what was that?
What is the 2 at the end?
It tells me how many sulfates I have. I needed
right.
2, right? 1,
Mhm.
2.
Mhm.
So it's, again, that subscript always tells me how many I have, right? So since sulfate is in parentheses, I'm telling you that I needed 2 of those. Does
Okay.
that make sense?
Yeah. Thank you.
Okay. Do you want to try another one?
Yeah.
Okay, so let's do aluminum. I could spell. Nitrite. Aluminum nitrite. Okay, so what's going to be my chemical formula?
You asked something?
Yes.
Can you repeat it?
I said, what would be my chemical formula for aluminum nitrite?
Oh, okay.
Nitrite. Okay. This is what Kevin wrote. And then you guys can tell me if you agree. Do you guys agree for aluminum nitrite? Oops, sorry. Not Kevin. Kevin wrote this. My bad. Okay, Alejandra. So you're close, but Kevin is actually NO2, right? Because nitrite is NO2. Nitrate is NO3. Okay, so Kevin is correct. AlNO2, the NO2 is in parentheses, and we have 3 of them. Okay. Questions? Concerns? Okay. Okay. So I'm going to stop here. And so that should allow you guys to do a little more homework. I'm actually going to extend your homework because I believe you have nomenclature in your first homework assignment. Is that correct?
Yes.
Okay. Okay, so I'm going to go ahead and let you guys go. I know it's a very, very short day overall, so enjoy the rest of your day. And like I said, I'm going to give you guys some extensions on the homework. And then next week, be prepared to do some nomenclature. So that's what we're doing right now. That's what you guys just did. So kind of make sure that you guys look over the lecture notes and make sure you have a good understanding about it. Okay?
Yes, sir.
Okay, so I'm gonna let you guys go. You have a good day. And then I will see you guys on Monday, hopefully face-to-face.
Dr. Henry, this lecture that we did right here, is it recorded so we can like rewatch it?
Yeah, I'll publish it. I always forget to publish them. And they're also located on my, and I'll send you guys an invite to my page, my YouTube page.
Okay.
Okay,
Okay.
thank you.
All right.
Thank you. Have a good day.
Dr. Henry.